In this video, we will talk about JavaScript numbers. We already covered this topic a bit in the previous videos. Link will be in the description, but here we will talk about more how to use numbers. So in JavaScript we have two types of numbers. It's regular numbers, for example this one, and big numbers. So we covered this topic. Big numbers was added recently in JavaScript because of it's not enough these numbers sometimes. For regular numbers we have two types of numbers. It's integer numbers, as I covered before, and floating numbers with decimal part, with dot. So how we can write these numbers? For example, let's create a billion, and it's one with 9 zeros. Yes, and one more. So, and here, as you see, there was some problem. It's very difficult to count a number of these zeros. And in case you need to add one or delete one, you can miss 1 0. To solve this problem in JavaScript, we can use another format using E letter. For example, 1 E 9. And it's the same representation of 1 billion. For million, 1 E 6. And we have 1 million. So how it works? It's the same as we would multiply 1, for example, 1 million. So it means that when you need to multiply some numbers, for example, you need 5 millions, 5 millions, it's the same as we multiplied 5 multiplied million. So here we see that we have 6 zeros, and then we will multiply this number on the 6 zeros, and the result is true because of it's the same number. Another issue when we need to represent very small numbers. For example, if we need to represent microseconds, the same 0, 5 zeros, and 1. It's 1 microsecond. But in the same case, we have the same problem. We can miss some 0, and then it will be another number. To solve this problem, we can represent the same second, E, and minus 6. And we will have the same number as we had here with 6 zeros, and it's 1 microsecond. It looks like we had, for example, for 4 microseconds. It's the same as we divide 4, divide 1 million, because of we need 6 zeros. And when we divide to 6 zeros, you will have the same value. Yes, 6 zeros, but here, as you see, I put 5. The same problem. We can easily miss 1 0. So this approach will help you to avoid such problem. Another one, how we can represent, as we know, numbers can be represented in a few types. It's based on 10. Numbers can be binary, octal, or hexadecimal, and decimal numbers, hexadecimal and decimal numbers. So right now we describe these numbers as a decimal because of basement is 10. But in JavaScript we can represent this number in another bit way. For example, 0xff, it's 255. Sometimes these numbers are used to represent colors in JavaScript, but from my experience I didn't use this format very often, or didn't use it at all. But sometimes you can find this number in the documentation, and you need to know what does it mean. It's using X. Also we can represent with binary. For example, this one is 255 in binary format, and octal with O, so don't miss 0 O, and the same number with octal format. And we can compare these numbers. As you see, it's the same number. Also, how we can handle this situation, because of it's not very easy to remember these numbers. So to solve this issue, we have toString function, built-in function. Usually when we're using this function, it works, for example, for 23 and 0.5 or 4 to string, we will get a string, but sometimes we can change the type of representation of this number. Right now it's a decimal numbers. Let's represent it in binary. So we have the same 255, and we want to represent it to string. But right now it causes error because of after the first dot we're expecting a floating part. So to solve this issue, I already showed it, we need to use 2 dots. It's not misprint, it's usual behavior. And now we see that we represent it as a string, but also in JavaScript we can represent it with another type. For example, if I put 2, now we see that it's binary format of this number. The same for all other formats. For 3, 4, 5, the same. Octal is 8 base, then 10 is by default value 10. The next 16, for example 32, and 32, so not 36, is the biggest number we can use. Let's try with 37. As you see, we have no result, there is error, so 36 is the biggest one. So using this approach, we can, for example, so let's imagine that we have 0 xff, so uppercase and lowercase is the same. Then to string, we want to binary it, so we have a string. Also, if we put plus, we will convert to a number. Right now it's a number. Type conversion I covered in another video, link will be in the description, so don't forget to check it if you don't remember how to do it. Okay, and now let's talk about numbers, floating numbers. For example, we have some number. So if you want to represent this number with the less numbers after a point, so you can use to fix it. And for example 2, it means that we need just 2 numbers after point, after dot, and as you see it's rounding this number. Because of 45 it's rounded to 5. So in another case we need more, or even we need even more. And it's interesting part because of we have some additional numbers. We will talk about these numbers later. Okay, so we can show some limited numbers of numbers after dot. Another case when we need round this number. In JavaScript we can use 4 different functions to round this number. So let's create this number. And the first one is math, object math, and floor. And we will get 2. It was rounded to full parse, and 3 it's less than 5, so we were rounded to 2. Another case, if in case we will use another number, same 2 but 6, 7, we have the same floor because of this rounds down. So if we have, it doesn't matter what you put to floating part, it always round to down. In our case we have 2. Opposite to function is Math.ceil. For my number we will have 3. It means even we had 2.3, it was rounded to bigger number, it rounds up to 3. The same to 9. Anyway, we will have 3. And now more usual function, it's Math.round. So for my number we will have 2 because of the next number 3, it's less than 5, so we are going to smaller part, but for 2. This one, for example, we will have 3. And the last function is Math.trunc. This function doesn't work in Internet Explorer, but who cares? Okay, and how it works, my number, we will get 2. Why? How it works, it just cut this section, so it returns just integer number. And the same, for example, if we want to Math.round minus, this we will have 2, in this case we will have 3, but for trunc we get just minus 2 because of we cut all floating part, so it's with rounding. Okay, the next one, let me show you very popular example in JavaScript. It's one more how you can represent numbers. So we can represent with the dot 0.1, but in the same case we can skip dot and use just dot 1. So dot 1 plus dot 2. As you see, it's not dot 3, and that's it. That's why sometimes we have some error or misunderstanding when we try to add. So as you see, we have false, but usually we would expect that 0.1 plus 0.2, it will be 0.3, but not. In real world, we have this number. For example, let's to fix it. As you see, it represents absolutely in another way. It's not 0.3 because of we have some representation number in JavaScript. So in JavaScript, internally, a number is represented in 64-bit format. And this format is EEE754. So in this format, we have exactly 64 bits to store a number. 52 of them are used to store a digits. 11 of them are used to store the position of the decimal point. This decimal point is stored for a position. And we have 1 bit to save a sign. For example, it might be a +1 or -1. Another interesting case based on it, zeros. In JavaScript we have two zeros. It's regular 0 or +0, and we have -0. As you see, it's -0, and let's take a look. +0, is it -0? But it's a true. So it's the same 0, but it's in representation of JavaScript is 2 different zeros. So in case we have a very big number, if we want to represent this, we will get infinity because of we have not enough numbers for in these 64 bits. That's why we have big numbers. In case we will use, as you see, we have counting, but for n we will get this number. Okay, and it's in our case we will have infinity, but for small numbers it's the same issue. If we want to, for example, 1 divide 3, we will get some infinity numbers because of it's not just 0.3. And that's why when we divide 1 by 10, for example, it's easy. And divide 2 by 10, we will have these numbers. We will get regular numbers, but when we divide 1 by 3, we will get endless number. That's why we have this case. And the last one what I want to show is parsing numbers. In JavaScript we need very often to parse numbers, and what can we use? For example, we have this string. So previously I showed you that we can use plus to parse it, but it works just with strings which contains only numbers for this one. Or for example, we can use it's a primitive wrapper, but it works in the same way. It works just for strings, regular strings. In JavaScript we can use parse int, and in this case we can use any what we want. It will get this number, but it doesn't work in this case. But we can use parse float. Parse float is for parsing floating numbers, decimal. And we have one dot, and for the second dot it skips, and it skips this part. So we can use parse int and parse float. It's in case if you are not sure. You're not sure will you get regular string which represents number, or you will get some string with some letters which are not numbers. So if you want to read more about numbers, I will put a link to the description with additional information how to use numbers in JavaScript. So thank you for watching.